Alright, we're going to be looking at how to use a hypsometer. And this is a device we built in class. It's a protractor and there's a straw here that we kind of look out. And we have a weight down here. And what happens is when we use the object, this turns and we're able to figure out our new angles, this being the obtuse angle, this being an acute angle. The acute angle here looking like it's maybe 62-ish, and the obtuse angle, if we look at the larger part, maybe 118, right? And that would be our new angle when we're turning it. So let's say we're actually looking at a wall and we're trying to use this device. We'll scroll down. Here's our little guy and we have our device. So first thing we need to know is our height to our eye. Okay, that's going to be really important. And I'm just going to use an arbitrary number. In this case, we're going to say to my eye is 6 feet. Okay, in other words, I'm probably a little bit taller, 6 feet, because my eyes are on the top of my head. But that's a nice, easy number for us to use. So the first thing I might want to do is I want to measure my angle to the bottom of some wall. Okay, and I don't even need to know how far I am from the wall to figure this stuff out. I only need to know the height to my eyes. So the first thing to do is we tilt our protractor down, okay? And this is going to create a new angle right here, okay? So that's the same idea as if we were to tilt it down like this, okay? And in this case, we're going to tilt it down and say it's roughly like that angle, okay? So there's a little theoretical one. So our new angle, here's an obtuse angle, okay? And it looks like the obtuse angle is at 120 degrees. So in other words, that's the angle extending past the eye. So I'll kind of put a new line in here. And this is our angle extending past the eye. That new angle being, like we said, 120 degrees, this new angle out here. What that also means, if we look at this, is the interior angle, let's kind of draw it like that, is 6 degrees, the interior of this small triangle here. So we know that that is 60 degrees. Oops. So that's going to be important for us because that angle in here is going to be 60 degrees. Okay. So right off the bat, we've already solved an angle, and using our SOHCAHTOA, we can use some of this information. The goal here is to figure out the height of this. So I'm going to kind of treat this like a non-right angle triangle, and I'm going to be looking at the larger triangle here. This is what I really want. So the next thing I really want to solve is for this side. Okay, and there's many ways you can go about doing this. This is the way I'm choosing to go about doing it. So because this is a right angle down here, okay, because that's a right angle, we know we can use our primary trig ratios. Specifically, we can use our cosine ratio. So cos theta, theta being an angle, is equal to the adjacent over the hypotenuse, okay? And the adjacent is the side that's attached to this angle, touching it. That's our 6 feet. And we're trying to find the hypotenuse. That's our h, okay? So in order to do this, we know that our angle is cos 60 degrees is equal to the adjacent is 6 feet, and our hypotenuse is our unknown. When you go about rearranging this, you eventually end up with hypotenuse is equal to 6 divided by cos 60. If you're unsure how I did that, maybe watch a primary trig ratio. Okay, so our hypotenuse is equal to, if we bring out our calculator here, we should be able to do it, 6 divided by brackets cos 60, and hopefully, oh, that's not the right one, 60, hopefully we're in degrees here. Oh, that won't give me, oh, I need another bracket. Nope, I don't think we're in degrees. Okay, we got a separate calculator here, so we'll put it in 6 divided by, and this one's a little different, so we have to put 60 first, cos n brackets equals 12. Okay, so our hypotenuse in this case is 12, and our unit was feet in what we're doing. So, in other words, what that is, and I'll highlight across here in yellow, that is the idea that this is 12 feet long. Okay, so that distance is 12 feet, which is great. Okay, now the next thing we're going to do is measure the angle of elevation with our hypsometer. So we would turn our protractor upwards. Okay, turn it upwards there with our line, and that's essentially the idea of doing this. And our new angle creates this. Okay, we're looking at an angle on something like this, so this is where we're measuring across. And if we take a look, and again, I'm going to try to use numbers that are helpful for us. I'm going to move this so it looks like it's actually really high up. I guess we should use better ones. Let's use a better one here. We won't use that. We'll use 130, we'll think, okay? Just so it's a little bit different. So looks similar to that. But anyways, again, it's all hypothetical, right? So this distance here is 130, okay? Sorry that does that. Which means this distance in here is 50 degrees. Okay, so that means that is 50 degrees. But the 130 is actually the really important part here, because that 130 is the distance from our eye line all the way up to here. So that's actually going to be the one we use. I'm going to show you how to use that, because it's important that we practice with our obtuse angles. Okay, so what that means, okay, is that, and I guess I'll do it in a different color, maybe purple here, that the distance from here, and we'll move this protractor out of the way now, the distance from here to here, like we said, is 130 degrees. Okay, so what that means, and we need to look at this, all of this is 130, and to here, or as you see I've drawn it there, is only 60 degrees. We have to find the difference. And the difference is this angle inside the larger triangle we're trying to find. So we have to find the difference of those two. So we're actually going to take those values, 130, our new number, 130 degrees, and we're going to subtract that 60 degrees. So when we track that 130 and that 60, we end up with 70 degrees. Okay, so the angle in here is 70 degrees. And at some points you might find obtuse angles, at some points you might find acute angles. It's kind of irrelevant for what we're doing, but that's important. So the interior angle here is 70. We know that this distance along here is 12. I can actually find this angle very quickly because I know that this entire thing's a right angle, right? And in terms of our smaller triangle, okay, this one is actually a right angle triangle. So if this is 60 and this is 90, that means this small part here must be 30 degrees, okay? So that small part there is technically 30 degrees. And if this greater idea here is 90, that means the distance here, and I guess I'll put it in blue so we can differentiate, is 60 degrees. So again, inside of our triangle, okay, we have quite a bit of information. This is 70, this is 60. That means we can figure this out because we know it all adds up to 180. So we take our 180 and we subtract our 60, which will give us 120. And then we subtract 70 from that 120. And what does that give us? Well, that's going to give us 50 degrees. So that this angle in here is 50 degrees. Okay, so we found all the interior angles. And what I want us to get used to is using our two laws that are really important. So because we have these interior angles, and I have the distance of here, the next thing I would like to solve, I'll call that x, is the distance across here. And that will help us finally finish this part here. So I would like to solve this. So what we're going to do, because I want to know how far away our heads were from when we were measuring also, and I'll highlight it here. And again, you don't have to take this route. There are, if you think about it, quicker ways to do this, but I want us to use sine and cosine law as we go through this. So because sine law, we have to use ratios of opposite sides and angles. We'll use this one and we'll use this one here. I'll set up our sine law. Our sine law, because we're solving for a side, I'll put a side on top. That's x over sine 60, because 60 was the opposite of it, is equal to the distance, which was 12 over sine 50. Okay, and really what this all means when we put it all together, this is 12 times sine 60 over sine 50. So our x, or other side of that triangle, will be equal to, and we'll have to figure out in our little calculator here, and hopefully I can do this all in one step. I already have the 12 in, so 12 times 60 sine equals, okay, divided by, and I'll put it in brackets, 50 sine, and brackets, is equal to 13.56, we'll write into 13.6 feet, approximately. So that means this distance here is about 13.6 feet long. Great. So that means from our head to the top of the wall was 13.6 feet. From our eye level to the bottom of the wall was 12 feet. How high is the wall itself? Well, this one, I have the interior angle and I have the measurement of the two outside lengths. I'm going to use cosine law to find this final height. Okay? And we'll call that our side C, since we're used to using cosine law like that. So our cosine law is c squared is equal to, okay, and if you don't remember doing cosine law, just kind of go over it again. But in our case, it's going to be 12 squared plus 13.6 squared minus 2 times 12 times 13.6 times cos, and our interior angle, which was 70. That is the angle that's opposite of this side. So we're going to go quickly about solving this. 12 squared is 144. 13.6 squared. Squared. 184.96. I'm going to round that, and that's actually going to round to 185. Okay. So it won't be perfect, but we're very close here. We'll then solve all of this in one shot. So this is the idea of, think of it like -2 times 12 times 13.6 times, and then this is cos 70, okay? So that's cos 70, that's what it's equal to. So I hit equals here, it gives me -111.6. So -111.6, okay? We'll combine all of that, and remember that c squared is equal to everything here. Okay, so we'll go through all of these steps. So I'm just going to quickly add 144 and 185. So we're looking at 217.4. 217.4, okay? And again, to isolate c, we need to square root it. 217.4. The square root of that will equal, and this will essentially be the height of our wall. So we square root this. We have 14.74. 14.74 feet. So in this case, the wall that we were looking at ended up being 14.74 feet tall. So this is how we can use our hypsometer. Again, there are simpler ways, but this is the way I would like us to do, because this way makes us practice a lot of our trig. We use a primary trig ratio, interior angle rules, we use our sine law, and we use cosine law, all to find that height. And only thing we need to know was some angles using our device, and the height. The only thing we truly measured with like a measuring tape was the height of our eyes to the ground.